All right, so we are streaming this live, so if you could kindly be as quiet as possible, all right, be a good audience, so that we only hear the speakers on the streaming. And then I know Elpis is also recording as well, so we can share it with the community after the presentation. I'm Karina Rader, the head of school here at RIS, and I've got Elpis sitting next to me, standing next to me. He's coming from Cyprus, one of our schools that Globe Educate just bought about a year ago.
Yeah.
A group of schools, the Pascal schools. He is doing amazing things at his school, and he inspired Globe Educate to then bring it to the other schools, as many schools as possible.
Yeah.
We're lucky to be one of those schools launching the Space Lab. This whole week has been full of Space Lab activities. A lot of the classes have been able to go into the Space Lab and work with Mr. Parker and Elpis and Sinead as well, our STEAM coordinators, to see how they can incorporate the Space Lab and all the fun technology we have in there into their lessons. And we'll be doing that throughout the year and next year and years to come, because the Space Lab is not just a place for technology classes, it's for all classes. And it's a great way to make sure that we have that cross-curricular activity incorporating STEAM, which is science. Who can tell me what STEAM stands for? I don't want to know. Yes, please.
S, science.
S, science.
Technology.
T, technology.
E, education.
Close. Engineering. Education, engineering. Good. A. Art, yes.
And math.
And math, yes. Very good. So I don't want to take up too much of the time, because this is for Elpis, who has been the inspiration behind the Space Lab. So I'm going to hand the microphone over to Elpis, and he's going to tell you more about everything he's been doing.
Thank you, Gorina. Thank you for the invitation. Thank you, guys. I'm going to take a lead from the question, and I'm going to continue that. We said STEAM, yeah. If we take it way back, Leonardo da Vinci said something a long time ago. He said to complete a full mind, a full vision, you need to understand maths in an artistic way and art in a mathematical way. That is STEAM education. It's understanding different disciplines with a different mindset. And a lot of schools take this the wrong way. They think that STEAM education, let's buy equipment, let's use it, but it's not. Like Leonardo da Vinci said, you need to understand the complexity and bring everything down to simplicity. So if you understand the technology in a very simple way, you can combine it with any subject that you like. History, it's not only about the sciences. You can combine history, geography, and so it's like a piece of art. The more you understand it, the more you can appreciate it. My name is Elpis Anastasiou. That's my full Greek name. Everybody calls me Elpis. And basically, 6 years ago, I was in my class having the biggest challenge in my life. I was teaching, and then my lesson was, let's say, not the best one. My students were getting high grades, but nobody was, let's say, challenged enough. They were not inspired to come happy in my class. And I was not inspired to be in that class with the same students, let's say, teaching the same curriculum every year. So we have an old saying in Cyprus: if you don't have a door to open for opportunity, build the door by yourself. So this is what I had to do. I had to think a way to inspire my class, my school, and my community. And we started with a very simple initiative, which was to send a space satellite. And it was funny because I remember Andreas, one of my students, said to me, "Sir, why don't we just build and send a satellite into space?" And I said, "Okay." let's go ahead, let's go and try to do it. And we downloaded a document, 101 from NASA, how to build a satellite. And it was built a model with Raspberry Pi or microcontrollers, tested with a weather balloon, which I'm going to show you in a bit, built a ground station, book a rocket, send it to space. Simple, let's say. So the first 3 years, we were ticking the boxes. Okay, we've done the experiment, we've done the ground station, we've done everything. We wrote a proposal even for European Space Agency, 1.5 million euro, and then COVID happened and everything was cancelled. But we were thinking the whole thing wrong. We had a gold mindset. We're ticking just boxes. So I remember that day that we thought, why don't we start sharing this knowledge with the community? And then our mindset shifted from a gold mindset to a growth mindset. It was not when are we going to get there, but how far can we get? How many knowledge can we share? So this gave me the ability to get a full scholarship in the Cyprus University of Technology, and I combined my ideas with the research to, let's say, close the gap globally when it comes to emerging technologies and education. Because just think about it, even AI just came through. We were the first school around the globe that did a chatbot called Einstein. I mean, OpenAI came out a month after we started innovating. And the way we were able to do that is because we developed the mindset of an entrepreneur in the school. We created an ecosystem. And basically, you have students saying, we're not going to listen what everybody's saying to us. We're going to research. We're going to find the findings. We're going to think of a solution. We're going to communicate with the experts and the universities, and we're going to make a company or a solution. So the whole initiative is basically based on 3 core values: to inspire, to educate, and to innovate. And it took me 6 years. I mean, half of the teaching I was doing was for the students, and they were teaching me at the same time. Because the projects you're going to see in a minute, they were like outside of the box, impossible missions. And to inspire your class, you can't just go in and say, you know, guys, we're going to use like some robot kit today to go front and backwards. It needs to be something that nobody else tried. And I found this from my experience. Young students, you know, they have an unlimited power in their brain more than us. And if you challenge them enough, and if you become what you want to teach, so you want to teach critical thinking, you need to be able to apply this to yourself. You want to teach entrepreneurship, you need to be the living example. Because if you fake it, they understand it. So it's a difficult process to inspire, but as soon as you make the first project and it's completed, then everything just seems not easy, but more, let's say, approachable. The second thing is to educate. So let's say you have an idea, you have the school, you have the community involved, and then you need to educate. And this is key, because every project I'm going to show now, it came without curriculum. When I started doing the projects, I look on the industry, and it's a common pattern. It's companies doing equipment that comes with a curriculum that ends up in a competition. And what do you teach the students? To follow instructions, to level themselves up to the point that they can go against, let's say, challenge with another school, with another student, or with another group. By my opinion, that's my personal opinion, this is not what you're going to do. Because I say this to all my students, the minute you limit yourself to go and compete with another school or group, it means you're not trying your best. You're not meant to fail. So all the projects I've done, we teach students how to teach themselves. So how do you build an AI chatbot? We did a course for 1 month. We teach them the basics, and then we told them, work together, find the solution. Come back to me in a month after. And this solves a big problem, because most of the projects that are out there, you need a teacher to be with them, to guide them through every step, and they don't really learn, let's say, how to survive in difficulties. Okay, and the next one is innovate. Ask any student in any school. Think of an amazing idea. They will come down with 1,000 ideas. But always the problem is that you need to be able to bring these ideas into reality. And this is what we did. I'm going to start from the beginning. The first ones was the space balloons, which is this one. So this, I'm going to show you a video in a minute. Daniel is going to help me. We do this experiment with a weather balloon, where we send a Pico satellite made by students, 90,000 feet up the sky, and we live stream it to around 300 schools in Cyprus. So it's an initiative that everybody is involved once a year. And our school actually does the training also for free for the rest of the schools in Cyprus. Another project we did after we finished the space centers in Cyprus, it was this one. This idea came from a primary school student, and you're going to see the video in a bit. This was the first robot we did in the school. So we said, let's do robotics. And I said, okay, we're going to do robotics. Let's do like something that nobody else did. And we brought a primary school student, and his idea was, let's do a space robot that looks like a spider, and let's make it like big as a house. Everybody started laughing, and I'm like, this is a brilliant idea. So we got the students to 3D print a small version of it. Then we got them to engage with the university, and then the companies to build it, and then COVID started. And I remember like today, I mean, it was a crazy idea from the beginning. I'm going to call it crazy because nobody else did this everywhere. And I remember the director, George, calling me and say, okay, Elpis, it's COVID, stay home, enough, like, let's do it after. I'm like, we started this super powerful training, it goes and it took a momentum. If we stop now, everything will fall down. So we built this robot in a month, which is record time. And not only we built it, but we took it on a big crane and we put it in central locations around the island. So millions of students would take in the car, going outside and see what we did, and they were able to interact with it also. Can we play the video? Thanks. So I make a short video, it's 3.5 minutes, and it actually more or less shows not all the projects, but some of them during the last 4 years. The first project is the one we did with Globe Educate. These are some of my students. So everything you see here, there was no curriculum involved. We just gave them the mission. So that's the Einstein we did. So we got the primary to talk with the thing, and then another 12 Globe Educate schools did their own character. Yeah, that was... This kid here, he's 18 years old. He has his own company. He paid for his school. He bought a car. He bought an office for his company. 18 years old. So we've been to a few events. The robot speaks like 5 languages: Italian, Russian. This is me doing the instructions for the schools. And these are some Globe Educate schools that were involved in the project. That's Nikola Tesla, if I believe. They make it in Larnaca in Cyprus. That's Ferrari Enzo. They make one in Milan. So we got basically all these schools to make their own character, and they learn how to use AI hands-on, not just in theory. That's in the UK. That one is not the BBC that we did the BBC called us and saw the project. They wanted to imitate the presenter.
I mean, Elpis, obviously, it really helps if you're able to work this out. They print the masks themselves, as we're looking at right now.
So that's the huge robot in COVID. So this Pico balloon that you see here, we have experiments from around 300 schools. So they watch the whole thing live from their classes. So it's just a huge event. And a year the students decided to put a small robot and set it into the stratosphere, and it actually worked in these degrees, and they recorded also the balloon exploding in that very height. So and everything you see here was designed by students, which is something, yeah.
Education and AI together.
So, so this is a, so all these projects here, as I said before, it's just to inspire. You have a group of students, and everybody's asking me, how can we get the amount of students to participate? You only need one student. And they've asked me on BBC when we had the presentation, how schools can do this, because everybody thinks that we had a huge amount of budget to do this, but it's not. We started the whole thing with 2 students and €150 budget. Everybody has €150, and everybody has 2 students. So, and the difficulties we found is what made us to be today, because we had no support. We had to do the promotion, engineering, project management. So as we growed, it was not only about programming and engineering, it was also, let's get the students to do the video, let's get the students to do the promotion, so everybody can participate. You just need a solid project to inspire, that's it. And then everything flows very normally. So everything falls down, what I just shown, under one umbrella, which is the Space Center. Okay, everything started from this place in Cyprus, and we took it from there to the next level. And the important thing about the Space Center, I say this story all the time. 6 years ago, they gave me like a very tiny room, and they came with a fancy design and say, we want this room to be black, we're gonna put planets there. Typical idea, yeah? So I've done my own thing, which was exactly the opposite. We did blue lightings and everything. And when they came to do the inauguration, I'm like, what is this? We haven't asked for this. I'm like, we don't care. Students gonna like it. And everybody was laughing because they know me how I proceed. So the whole design of the Space Center was done by students. So that's big value. Again, the history is very simple. We started with €150 for the project. We took it the next year. I remember it was very little money, around €5,000 in our pocket to do the space centers. So we got sponsorships. We built 6 years ago, it was the first space center around the globe in a school. So again, if the idea is big, you find the people to help you out. And then we did another 2 in Cyprus. Then Globe Educate came and helped us out. They saw the vision, and now we have another 9 in Rome, in Milan, London, in Paris. And then one of the most important things is the space. It's called Space Lab or Space Center because we started as a space project, but space as the acronym means a lot more. So space, it's skill development. It's about doing a project that is, project-based, is hands-on. Again, you can use a space center as an alternative assessment. Get a group of students, get them a project, incorporate your curriculum, and get them to provide the results. Collaboration, it's very important. Every single project we did, it was never about who is the best student, the best school, the best teacher. It was always, how can we become the best version of ourselves? So everybody can participate. It's not like, let's get a curriculum, let's see who is the best, and let's give him a trophy. No. Let's collaborate with the space centers. Let's collaborate with the projects. Let's teach them how to work together and make incredible results. And the last one, I love this one, is education for the community. When we finish a space center, I remember I had a meeting with the management, and I told them, I want to give this for free to the whole community. And they're like, we've invested so much, are we going to share this for free? And I remember an old friend of mine from Greece, he told me like, Elpis, if you do something amazing, if you don't share it, it's going to get forgotten. Share the knowledge. And we have now a collaboration with more than 300 schools in Cyprus, and we got so much back just from sharing. It's just simple. So any project that we're going to do in the future, it needs to have this community involvement. Something to keep the Space Center sustainable, establish an engineering club. Get the students to visit the experts. Simple as that. Get them to see the scientists in the university. You have a space lab, the only space lab in Rome, and just around the corner is European Space Agency. You can visit them, and I'm sure they're going to love the idea. Community engagement, again, we can do a project that is going to be involving the whole community. Networking collaboration can happen from the engineering club. So if you visit universities, they normally do projects, and they would love like school to be actively involved in a project. And this is also very important. You need to reach for the skies year and every year and every year. Never settle down and think that you actually completed everything. Benefits for the students, I think the most important thing is creativity. I mean, and of course critical thinking and collaboration and everything, but with AI, you know, we're losing a little bit of, when it comes to, let's say even the creativity. You can get an AI to imagine, get some ideas. But I think from all these projects, especially this one, which I'm going to present now, you can get students to, if they understand the technology through experiences, they can then come back and reverse engineer the solutions that they're going to provide. The concept basically that we did this year, and this is one of the biggest projects I've done. It took me a month to figure it out, because this is what we're going to do this year with all the global education schools, including RIS Rome. And everything you see here starts from the primary and then ends up in the secondary. And all the technologies now, they are centered in an experience. So for example, you want to teach primary school about ecosystems. This is a terrarium. It's a closed loop, let's say, ecosystem. So when they build this and they put something that was not supposed to be there, they understand that every single thing that you change in an environment has a side effect. And then we move on to smart gardens, which is an open loop system. And then you move to smart microscopes, so they can investigate. We gave an experience to the secondary school when they downloaded pictures from satellites, they converted them into 3D, and then they print them out so they can visualize how the city is. Then another experience that we have is the sensors. So we produce very small sensors, 6 in total, and the secondary school students will imagine that their school is a city, and they will place different sensors around the school, so they can simulate, let's say. And that's just simulation. Then for the upper school, we developed a sensor that is this small, one of the smallest in existence, with a lifespan of 3 years. So they will place this in some vehicle, and they're going to take the real data from Rome. So the end result would be to do some actual research. You're going to receive, Corina, this is amazing. You're going to receive a small chatbot, which is like a flower pot. And we designed it so it can speak and interact with the primary school about sustainability. It's almost ready. I didn't realize I was going to make it this year, but it's done. I was super impressed. It's so cute. It's like this big. But again, you're going to have students interacting with AI in a very, let's say, responsible and ethical way, because the robot can explain to primary school students very complex terms in very simple words. Very easy. So any teacher can get this, go in their class, put it, speak with the students. Simple as that. You get them excited, you get them inspired. So it all ends up something like this, okay? So they 3D printed their city. They're collecting data. You're going to receive a ground station that actually students can compare the data from the school, the data from the city, pictures from satellites, and then get AI to understand all this to come into conclusions. The best part, they can reuse every year the same hardware, the same mindset. So as they get more familiarized with the technology, the project will grow also. So it's an infinite loop of experiences that would teach kids Earth observation, artificial intelligence, robotics, how to get from simulations to real life research. So again, I'm really excited about this because it's going to run for around 6 years. So it all ends up here: inspire, educate, innovate, and connect. That's the key formula to anything that you do. And I'm really proud of this because I was in a position to grow in a very typical learning environment, which led me to have a disappointing, let's say, work experience. So the mission behind this is to give the opportunity for all the kids and all the students to think differently, you know. Thank you. Thank you very much. And if you have any questions, let me know. And I'm gonna.
Okay, so do we have any questions? I've got some homework for the students. It's good, it's fun homework. But how many of you have gone into the Space Lab? Raise your hand if you've gone into the Space Lab. Okay, good. And how many of you guys were inspired after hearing Elpis talk today?
I hope so.
So, I want that inspiration. I want your ideas to come to me. So if you have any ideas for some projects that we can do at RIS Rome, some balloons going into space,
Yeah.
a big giant spider robot, come up with your own idea,
Yeah.
original, inspirational, and send it to me, okay? And we can see if we can launch something for next year or even this year. We still have time.
What I said to Corina before is, if you're not supposed to do what we did, you know, because this was our own ideas. And I said before, I come from Cyprus. It's a very, very tiny island. So it was very, very difficult to do this. You are in Italy, in Rome, you know. So if you think of an idea that is going to be your idea, your own baby, yeah, I can write the proposal for you. I can make the whole thing, you know, how you're going to proceed. And then you can actually use that proposal to get communication funding and everything. So I'm more than willing, because I remember yesterday when I came into the school, I'm just walking down and I see the Space Lab. It's so nice and beautiful there, and everybody's so inspired that I really want to help you, you know, to, I don't know, fast forward you 6 years into the future, not to have to go through the same hassle and troubles that we've been. So just think of an idea, any idea. Don't think, this is too funny, it's impossible, or it cannot be done. That's where the value is. After, this is how I always do this. I get my students to write what they can, and then the next day, you come down and I tell them, okay, now you can do this. Write down what is impossible to be done. So that's where the investment in your time, and also you know, hello John, how are you? This is where the secret lies, okay? So, yeah.
You asked about elementary students.
Yeah.
What kind of projects you've done with kids who are like 9, 10? What type of things?
Basically, the project we have, this one, so if I was you to starting down with the Space Lab and everything, these experiences are very important because it's all about sustainability, using the equipment, understanding the basics. But then when it comes to idea and let's say innovate, you can get any idea down. The biggest problem is get the very outside the box idea, and students, primary school students are very good in this because they don't see the limitations. We, as adults, we have these mechanisms that says, okay, don't think about this because it's not possible, it's going to be difficult. Students don't have this, so if you ask them, think about something, they're just going to write down and produce amazing ideas. So if I was to start with some activities, these are very nice, and it would get them inspired, especially with the microscope and the terrarium and the smart garden, and then you can take them out to the lane of innovation, let's say. Yeah?
Which school is it?
Which what?
Which school is your school?
My school, it's called Pascali Larnaca. A very nice school. But yeah, this is always what I say, if you involve the students and the teachers, you can do amazing things. Another added value on these projects, especially for the secondary, is when they go to university. It's so much, it's incredible when they see that the school students have actually got involved in something amazing as projects like this. So it's another value for all the ages. Any other questions?
I'm just curious to know about the, I don't know in English, you send something to the space.
Yes.
A satellite called Pascal.
Yeah, it's like it's a small picosat. It's a simulation of a satellite, and we have students to build it using Arduino. There was an actually workshop the other day from a university here, and we're gonna think to collaborate with them next year. So you can build, let's say, a satellite, and we can facilitate this launch, and you can watch it.
No, you follow up with the satellite or what? You just send it and it comes back there.
Yeah, it goes up. It's very expensive to send something with a rocket. So what we do is simulate that is with a weather balloon. So it goes up for around 3 hours, and then it's like pops out the balloon, then it comes down with the difficult thing, and we didn't know this, is that you have no control on this device. So if you control it, it means a UAV, and it's military. So you're not allowed. So you have students to calculate how do you send 1 kilo picosatellite with a weather balloon, 90,000 feet, and they have to calculate where it's going to land. And if you know, Cyprus is a very small island, it's surrounded by sea. So the whole thing is just mind-blowing, difficult, and nobody has tried it nowhere. So they solved a problem that researchers couldn't solve in a school with 16-year-old kids. And I asked them, how did you do it? And they went, oh, it was easy. We just went here and there and there, and then we did it. And I've shared this research with universities and the government, and they were like, there's no way, you got lucky, and you know. And then, okay, watch it next year. And we did it, I think, 10 times until now.
How close did you get?
We got,
To where we land? How close did you get to predict where we land? I'm curious. 3 kilometers, 5 kilometers?
the second time we did it, that was another funny story. A fisherman found it because we lost it. It was a failure. And a fisherman found it in the middle of the ocean, and they thought that we sent the fisherman to find it. By the way, it's impossible, yeah? In the middle of the ocean, GPS doesn't work. Anyway, he found it, he brought it, but we got an accuracy around 3 kilometers, which is mind-blowing. It's like you're having a slingshot, you just launch it, it goes there 90,000 feet, and then you need to calculate the descent and also the ascent, where it's going to land with the weather data. So these students now that they were involved, they were able to use real-life data, solve a problem, and the value is not that they solved this problem, but they found the formula within themselves to solve any problem in their life, just by getting the project like that into the stratosphere. So we do this live stream with all the schools in Cyprus for one single reason, to get them inspired to do this, because if you saw a student that is 15 years old doing something like this, you say, I can't do this, I can't try. So that's the value of these projects. Yes? What?
It's at a school. A school.
Okay. You mean when it goes down, yeah? Listen, this is the problems, this is the challenges that we had to come against, because I gave all the problems to the students. I told them, okay, what if it lands to someone's house or someone's head? That's another history. You need to be, so they actually managed to do the research. I helped them a bit when they were like stressed out, but this is a student-run program. I got stressed the first year when I was going to launch it with a minimum amount of money, and then when the government came and backed it up, I gave them the budget and I told them, okay, use it to solve the problems. Don't come back to me if you don't have like a really difficult question. That's where it goes. That's real life, is not to guide them through every problem. But it would be amazing, you know, because you already have a collaboration with this university now, that they do Arduino. I spoke with a guy yesterday, his window is looking at the European Space Agency in Italy. And I'm actually going to contact him with the experiment. So if we're going to do this, you're actually going to run the, yeah. And it's going to be hopefully for Rome, all the schools in Rome. And then if you wish to, you can actually lead it as a national program that as we do. So you're going to have every school in Italy running it. It's up to you. It's, yeah.
Just for clarification for students, we will have next year from October to March
Yeah.
all these projects for machine learning. We already have.
You already have up to the point that is there, and then I'm working really hard when I go home to give you this.
Okay.
But as soon as you have it, I designed this project not to give stress to the school that they need to take it to the max, because they can start this year, okay, let's do the terrarium, let's learn the smart gardens and the microscope. And then they can elevate this next year when they understood it better, because you cannot inject knowledge the same you do with a computer. They need to understand it, use it, and then elaborate with it. So it takes time. So yeah, you're going to have all the equipment this year. I think in a level of completeness, you're going to be able to achieve, I don't know, 65% of what the abilities of all the equipment is. And then next year, you can actually reuse it, because you can change the scenario from cities to forest. You are surrounded by forest. You can change the scenario anywhere you like. I mean, the possibilities are endless. And you have amazing leadership here and team, so it's going to be a bless. Thank you. Thank you very much.